Quickly, is that a county-wide effort or
So
pedal or city or?
the food waste collection happens from 3 places around the county. It happens at the Walmart in Pendleton. It happens at the Walmart and the Eastern Oregon Correctional Institute. And so one thing that he said was the human power out of this is really a big challenge. That it takes a lot of manpower, woman power, human power to move to like sift through.
Yeah.
Because and then contamination is a huge problem. That's one of the things that he said is it has to be clean because otherwise it creates a huge problem. And so they've had intake days. They are actually required to note when there's too high of a contamination because that all goes in landfill. If there's too high of a contamination, it goes into the landfill. And so that is something that they track, and that is something to be aware of with this kind of effort. Is that it does require a lot of people. But if we're talking about places to invest some of this money, getting folks on the ground, like we just saw the Biden administration talk about their climate core.
Yeah.
One of the amazing for the climate core is to implement some people to literally just, if I know it wouldn't be the most fun job, but some of us like trash.
Yeah. That's sifted through trash.
I'm a garbage person, and so people be able to like be on the ground in these stinky jobs, doing this work, because it is really important work, and the important work is usually the stinky one.
Thank you. You said that yesterday about those 3 main ones. As I was watching it, I was thinking about individual because in Hood River, we have the curbside, but I've never seen how it's all processed. And so, yeah, I was actually curious about that. But it's 3 main places. So that's really cool. That's a great.
I would be interested in learning more about that approach too. So he said that his operation and then in LeGrand is the only place. So I would be interested.
Because I know Portland probably, has been doing that for a while, but I know for us, it's been maybe the last year. So yeah, I'd be happy. But you made me want to like go and watch it now. Like, how's it actually going and how's it all working?
Yeah. It's fun stuff. Learn with plastics. It's not always going where you think that.
No, exactly.
How about C101?
Okay, my name's DeArcie Abraham. I was known for redworm composting. I changed my name to BioWaste Technologies. I'm going to be focusing on some anaerobic digestion and imply some composting in there. I'm not really sure which way we're going to go with that yet. This is my community composting 101 presentation. Go ahead. And I'm just going to name some reasons why we compost and the environmental impact that we can make at home. Difference we can make. Next slide. So to reduce your waste, 50% of municipal garbage is compostable. And number 2, to enhance your soil. It increases soil fertility and suppresses plant disease, improves soil structure, increases microbial activity, and water retention capacity. 3, you can grow your community. Community composting gets people to engage with each other and how their food is grown. Making compost creates 4 times more jobs per ton than landfills and incarcerators. Or to protect your climate. Food scraps in landfills and incarcerators generate pollutions like methane, but food scraps converted into compost actually sequesters carbon. Oh, is that, yeah, incinerate. Yeah. Okay, and the emissions. Landfilling food scraps produces 20 times the CO2 emissions as methane as compost. And when used, compost net emissions becomes negative. Landfills are the 3rd largest source of human-related methane emissions in the US by 15%. 2, it enhances soil quality. Nutrition in the soil grow healthier, more nutritious plants and food, reduces use for synthetic nitrogen and fossil fuel intensive fuels, water holding capacity, increases soil resiliency to extreme heat and flooding. Soil aggregation prevents erosion, runoff, thus protecting and restoring waterways. World soil holds 1.5 trillion tons of carbon in the form of organic matter. What's one of the best ways to build soil organic matter? Compost. Degraded soil actually releases carbon, but a one-time application of compost can make soil a carbon sink again. Just 1 acre amended with compost can sequester up to 75% of a car's annual emissions. Compost also increases crop yield and vegetation, leading to even more carbon sequestration. Healthy soils equal food security, profitable farms, and enhanced habitat. Degraded soils have been linked historically to the fall of civilization. Here's some good statistics I like about composting. Composting enhances soil and protects watershed. Healthy soils are essential for protecting watershed. Compost is the best way to add organic matter, which is vital to soils. When added to soil, compost can filter out urban stormwater pollutants by an astonishing 60 to 95%. All about the soil. Compost improves biological, chemical, and physical characteristics of soil, enhances plant disease suppression, increases soil fertility, increases microbial activity, protects against soil desertification and soil erosion, increases resilience to floods and droughts, reduces need for chemicals, converts nitrogen into a more stable and less mobile form, and phosphorus into a less soluble form. Improves water retention, improves soil structure, adds humus, keeping soil particles stuck together. Improves ability to store nutrients such as
The cation exchange.
the cation.
Yeah.
How do you say that?
It's cation exchange.
Okay. Cation exchange capacity. Compost serves as a filter and sludge. It immobilizes and degrades pollutants, improving water quality. Compost also helps reduce stormwater runoff. Compost equals climate and soil protection strategy, prevents landfill methane emissions, adds carbon to soil, improves soil ability to store carbon, improves plant growth and thus carbon sequestration, reduces need for energy-intensive fertilizers, pesticides, and fungicides, reduces energy for irrigation. This is how much food is being composted. We're showing about like a 4% range over there. The yellow is donated, and these are all by the EPA food waste hierarchy triangle. The brown is animal feed, which the bad food would go to animals. And then the blue piece is anaerobic digestion. That's a little bit more popular than the composting. At the bottom, you see there's a large percentage of yard trimmings already being composted. Food waste is still neglected. What is compost? It's a dark, crumbly, earthy smelling product of the decomposition of organic matter, a living soil amendment that improves soil physical, biological, and chemical properties, enhances soil ability to support plants and beneficial organisms. What do we waste? What is compostable? 37% is going to be other, including glass, metals, plastics, rubber, leather, and textiles. 23.1 is paper and cardboard. 6.2% is wood, and 12.1% is yard trimmings, and 21.6% is food. Here's the food web. So there's going to be bacterias, molds, and other organisms labeled as one. There is the earthworm, land snails, and slugs, and those get eaten by the number 2s, which would be the soil flatworm, roundworms, mold mites, beetle mites, and then number 2s through 3s would be ground beetles, scorpions, ants, predatory mites, centipedes. Those are going to eat the number 2s. number ones. This is a photo example from Kentucky University on what worm castings can do for our water. And so over here is depleted farmland, where you see that brown water has seeped through and is not very filtered. Here in the middle is compost. It's still a little color to it, but where you see here the worm castings on the left, that's drinkable water. Composting 101. Composting is a controlled aerobic decomposition of raw organic materials such as food waste and dried leaves via fungi, bacteria, and other microbes in order to create compost, a dark, crumbly, earthly smelling soil. It reduces waste, enhances soil, protects the climates, and grows communities. Here's some examples of what not to put in your compost. Really try to avoid the meat and the dairy products. You're going to get pests and you're going to get an anaerobic condition. Those are not wanted. So over here in the greens and browns, you always want less greens and more browns. The more browns you have, as you heard in Pendleton Sanitary's presentation, he goes 5 to 1 nitrogen. So that covers it good enough so that there's no odor and there's no pest and there's less chance of an anaerobic condition. Again, greens, fresh materials that are relatively high in nitrogen, and browns are materials that are relatively high in carbon. There's 4 ingredients you need for composting. We need the greens, the browns, we need air, water, and a lot of that food waste creates the water needed in your compost. We can collect our food waste and put it in our freezer, put it right straight into our bin, save it for later and chop up. Always make sure to chop it up into smaller pieces so that it's able to compost faster. 2 to 6 inches is what's. So here's some recipes. There's a lasagna method which I use at home in my continuous flow bin. I use I practice vermiculture at home. So I use the lasagna method where I'm putting my greens once a week and then putting my browns on top. And that creates enough heat for the worms to live throughout the winter and feed off of. And they multiply in their population. Every 6 weeks they double. There's the small hole pile, which we'll see in another slide. Right here. This slide right here shows the dimension of what your pile should look like. It's really recommended to be about the size of a washer machine. And you're going to have 3 to 4 feet of waste in the middle and 3 feet out of carbon to prevent the odors and the pests.
And that was something that we missed in the video, was they immediately covered that food waste with the other wood material. So they dumped the food waste and then there was a bulldozer that came behind it.
It's also mentioned that he hasn't had any problems, and I believe that's because he used the 5 to 1 method.
Yeah. Having too much nitrogen was part of the problem that we highlighted, that it creates that odor problem, and then you get what he described as vectors. It's the animals.
Right. Cover and expose greens with brown. Cover any exposed greens with browns. We kind of went over this. Aerate and mix regularly. There's aerated static piles you can do. You can do a bin. You can do the lasagna method. You could build a pile. You can use a tumbler. You just gotta always make sure that there's a bio layer on top so that we can protect ourselves from anaerobic conditions, pests, and odors. Let's click through. One more. So after your compost is done, which is going to be about 6 months, with worms, 6 weeks, we're going to let it cure, and then we're going to do a squeeze test. We squeeze our compost. There should only be a few drips of water that comes out between your knuckles, and I think that's about everything. That includes everything. I would like to add that like 1 head of lettuce can take up 20 years to
Break down.
It decomposed, yes. 20 years it decomposed in a landfill. It will never touch soil. It will turn into an anaerobic stage. And those 20 years it's releasing methane into our environment. With composting, we're adding all the nutrition is needed and we can eliminate that head of lettuce 1 week. USDA, FDA, and EPA will release funds to farmers. These funds will assist farmers to transition into safer practices. Kate Brown declared in 2020 DEQ to take actions to prevent and reduce food waste by 50% by 2030.
Thank you.
Okay.
Highlighted in terms of challenges, and I'll get to your question in a second. Challenges that he experiences with his operation. And I missed this in the video, it shut off on me, unfortunately. They do those big piles instead of the windrows, and that was specific to our area because of the temperature that we get to in the summertime, and the wind actually takes a lot of moisture out of that. And so they collect them in big piles, but they're not static. They turn them constantly. And then the other thing he highlighted was access to water was actually kind of something that was a challenge for them. Not currently their operation, but he thought that that would be something to highlight for anyone that wants to kind of take this on, is that you do have to kind of add water to this. If you're, especially with that 5-to-1 ratio, like that's a lot of carbon. Yeah. That they were actively, they had like little pool there that they were pulling from, that they watered them periodically. People do the sprinklers. Yeah, exactly. And so those were a couple of things that he highlighted. Another challenge that he's talked about was the input output. So you got to have, especially if you're, and we'll talk about anaerobic digesters here in a second. If you are relying on that for, you got to have a constant supply of material in, and you got to have a buyer for it on the outside, somewhere to take it. And so they actually experienced the reverse problem of some of these other methane capture ones, is that they don't have enough people to take the compost away. They can't give it away fast enough. They can't give it away because you have to run an operation. And so that is something to consider for both composting and anaerobic digestion projects, is you got to have steady in and you got to have steady out. Questions?
Thank you.
I have one. Nice presentation, thank you.
Oh, thank you.
My question is really the scale. I mean, I understand what you're doing at home as far as composting and how people can do that. What does this look like on a industrial agriculture scale? I mean, you're talking about buyers. I mean, we want to influence more people to use it, right? What scale would it be used in an agricultural operation? I mean, could we treat 50 acres, 1 acre? I guess that's.
I know for worm castings, it takes a gallon to make tea for 1 acre. So you would 1 gallon would cover 1 acre in worm castings. With compost, a 1/4 inch applied. I read a study, a 1/4 inch applied to a 60,000 acre rangeland had sequestered all of the carbon that sequestered the carbon released by LA County. So that was like a really interesting study I read. I know that if I wanted to treat it as a county-based program, it would take at least 4 acres. For the reservation, I think, you know, 1 acre would be fair. I say 4 acres on a county base with windrows. The piles that were made at Pendleton Sanitary, that was all on a half acre.
Real small.
It was like a half acre. He had like 7 or 8 piles there.
And that was something that he highlighted, space.
Yeah, space.
And in terms of end consumers, one of his biggest buyers, like the place where his compost goes the most, is an organic orchardist in the area. And so there are people who are trying to do this, but then he also really highlighted that this is great fill material too. He was talking about how he took some personally for some property that he has that needed some fill, and it just like took off. It was like really productive and cheaper than some of this other higher quality fill soil. And so we can look at it for construction options, especially if we're talking about permeable landscapes that are spongy and can absorb some of these floodwaters. Compost is great for that. And so if we're looking at construction projects that might be threatened by floodwaters, that might be a great option for them.
You actually hit on what my real question here is. When you're talking about the end consumer here being an organic farm. what the materials that are being brought in there are those all certified organic materials to begin with? And how does that farm keep their organic certification if
That's a
you're
great
putting
question.
back in material that you don't know the provenance of?
And I could really get into the weeds with you about organic certification, because this is actually, my master's in agriculture, I work on the
Yeah.
organic farm, and record keeping was part of that. I don't know that that would be productive for this conversation.
It's just a question of mine. I mean, it came to mind that if we're talking about this, there's lots of little details that go into this that we have to think.
Absolutely, and the record keeping for organic certification is meticulous,
Yeah.
so this is actually legitimately a consideration. I don't think his is certified. I would love to talk with that orchardist about how that
Yeah.
works in with their
Just
certification.
curiosity, thank you.
Absolutely, yeah, something to follow up on. Thank you, DeArcie.
Okay, thank you. One more question.
Yeah.
Is he turning folks away from using this option? Like there's 2 Walmarts, there's, you know, like in terms of the food waste coming to.
Yeah, that's a great question. And that was something I talked about last night, but forgot to touch on today, is the price that they charge their consumers, like the people they're taking waste from. Their food waste collection is the same price as the garbage. There's a law in Oregon that you are not allowed to charge more for food waste collection than for garbage. So it is set at that same rate. So there is no financial disincentive to not be doing this, other than the labor. So the reason that he takes from the Walmart in Pendleton, the Walmart in Hermiston, and more importantly, the prison, is that, again, using his words, unlimited labor from the prison. Again, I have some poems about that. But his words, not mine. And so labor really is where we see this. You know, I've talked to him a number of times. Like I love garbage, and so I've gone and toured this operation a couple times. He talks about the fact that he's approached Wild Horse before to do intake, like taking food waste from Wild Horse, and they have decided that it wasn't worth it for them because they would have additional staff requirements to divert the food waste from the garbage, from the meat, then from the plant material. So it is a labor requirement.
Piece. So there's a programming that was started in California called the Green Janitor Program, and the Portland Clean Energy Fund is piloting something in the Portland area that we're supporting as well. That was really kind of focused on almost exactly on that the janitors and you know, office buildings, there's a lot of decisions that they make about recycling, about composting, about bringing lights on and off that could be supporting, you know, energy savings and choices that the community makes. So that's, I mean, rather there's maybe an opportunity to be thinking, you know, programmatically about funding for something like that at Wild Horse or other places locally where that's actually, you know, there's funding for somebody to do that, or there's training, and then being able to, there's some pretty cool things that they do with the Green Janitor Program, because you're bringing everybody, all the janitors in, doing that sort of training, following up. And then now you're also talking to a bunch of all the schools, and you're talking to all those folks in housekeeping and in janitorial work, that you can also have conversations with them about energy savings, composting at their homes. These are all people in their own homes. So it's kind of an opportunity maybe to think about.
Yeah, I love that. And I think that one of the things that we might look at for some of this implementation, that kind of work. We're fighting convenience, unfortunately. It's very easy to just pitch everything into the garbage and not have to think about it again. This is asking people to do things differently, and that's always a challenge. It's kind of the crux of this whole conversation, is asking people to do differently. It's great if you can provide financial.
So that was the Green Janitor Program? And they do training?
They had created curriculum, and then Portland right now through SEIU. SEIU is leading that.
Thank you.
Questions, conversations about composting?
I just wanted to add, I definitely would like to look more at the Hood River, because we don't even split out the meat and cheese. And yeah,
We
and
gotta follow up on that.
yeah, and there's about, I mean, there's an entire company, Dirt Hugger, that is the seller of the compost. So there's that partnership. So if there's the need, you know, or the consumers that want the compost, maybe it's not all orchardists, but just individuals that are having their own, you know, raised beds. I feel like it's a pretty big business. Yeah.
PSSI sells to the public, so you can go out and buy compost out of your truck, and it's a great rate. Like if you were buying bags of stuff at Walmart.
It's a lot,
more
yeah.
expensive. Yeah. the management of what goes in there. So we get a lot of like seeds sometimes, so it's definitely.
Yeah, no, I hear you.
That's possible too. Yes, and feasible.
Yeah, I know for like the home thing, that's not something I would be doing, but the way that we process it is. And it sounds like bigger, like cities in Portland.
Yeah, Portland takes it and everything, but they just get, I think it's must be.
So hot.
Yeah, I guess it's hot, but they don't worry about it. And for that reason, because then it's a lot easier that you can just say, put it all in there.
It kills the weed seeds, but it also kills beneficials.
After 160 degrees, it will kill.
Kills pathogens. But
Yeah.
well, I'm gonna, yeah, thank you, DRC. One more round of applause. Feels like a natural segue to go to anaerobic digestion, but then, Jason, I'm gonna put you on deck. That's okay. Like, we're up next. Is that
Yeah.
okay for you?
Yeah.
Okay.
Be right back.
There we go. Nothing happened. So again, natural segue to this is we've been talking a lot about methane, and methane, there's really, it feels like really low hanging fruit here. Because this is all going into the garbage right now, and not only are our landfills really filling up, it's also creating methane. And so we've talked about soil carbon as a way to get around that, composting is a way to get around that. I wanted to anaerobic digesters. So again, methane is really potent over the short period of time and over the long period of time. And so if we can divert biological materials from breaking down in landfills, we are going to be preventing carbon from being released. So a digester, basically, DeArcie talked about composting, which is the aerobic, so with oxygen. That's how composting is created. If you are doing decomposition without oxygen, that is anaerobic, without oxygen. And so this process that we said has created methane, which we want to prevent, but we can also harness. And so that is basically the summary of what an anaerobic digester is it's taking in organic material, it's decomposing it with microbes that create methane specifically, and it's keeping that in a sealed environment so that we are harnessing and pumping out that methane for different purposes. Now, methane can go to a couple different places. If you are using it as a direct fuel, it's called renewable natural gas is the industry term for that. And basically, it's just that. It's burning it like you burn natural gas in your home to heat your home, a lot of us. Gas is used to have electrification as well. And so those are still benefits that you can have with an anaerobic digester. You can either burn it directly or you can burn it to electrify things. So basically boil water, it turns a turbine, like he was saying with the biomass energy. The problem, so there's some risks and benefits with that. The benefit is you're preventing methane from being released. The truth of it too is that it's not carbon negative. So you're not burning carbon, because when you burn methane, it becomes carbon dioxide, which is released into the environment. And so while preventing methane, you are still releasing carbon dioxide. You're preventing a worse thing from happening than would otherwise happen. You're still releasing carbon. And then for particularly large scale digester operations, there is a concern about potential groundwater contamination. Some of these pools, these lagoons where they keep this biological material, if they are not sealed properly or constructed properly, there is potential for them to leach into the groundwater, which we already have a groundwater problem or nitrate problem in our aquifers right now. And so that would be something to keep an eye on. But then there's also there's a question of odor too. So when you're decomposing things, and Mike said this as well, it's the particularly sticky stuff when you're decomposing without oxygen. And so communities that are located directly adjacent to some of these digesters have expressed discontent with these processes because they are having to live day after day with what is a very unpleasant smell. And so those are some realistic things to consider about digesters. And then again, we have a really great example of that happening already. 3 Mile Canyon Farm dairy out in Boardman, Oregon. They have a large dairy operation, so lots of cows leave themselves and they poop. And so they take this cow manure and they put it in their lagoons. And basically it's just a big concrete pit with a tarp over the top of it. It's a very uncomplicated technology, these digesters. And so they take that methane that is produced through that decomposition process. And for a while, I know that they were powering their operation. They were not able to be here with us today, but they said that they haven't been able to do that for a while, but they weren't really forthcoming on the details of why that is. And so I'm really, really curious as to what has interrupted their using that supply to power their operation. But what they do then instead is they are able to sell those offset credits to the carbon markets in California. And so they actually get money for preventing that methane from being released. And so this is something that we could consider here, maybe not on this scale. A lot of the conversation around anaerobic digesters is with confined animal feeding operations, very large animal operations. But as DeArcie has highlighted with the compost, you can do it at a small home scale. And we're actually investigating potential for those home biogas systems for home food waste to be able to be put into these little tiny scale systems that then produce a direct fuel for like cooking on a range, like a barbecue, basically. And so while it's the anaerobic digesters are things that are being implemented at a very large and potentially harmful scale, there is opportunity for us to do this in a different way. So I will welcome questions, comments.
It's really exciting. I love the idea of the small scale and especially like testing it out at the Longhouse. Like I think as you've mentioned, I'm curious where it's been done before. Like, has it been done before? Like the product exists, so there must be some examples. And I guess also like, are other tribal nations also considering this type of potential solution, or have you heard of any interest?
So I don't have any good examples right here of some of the small scale ones. We did find some videos of places, other places in the world that have been doing this. So there was a video of pastoralists in Kenya who actually they were taking the waste from their pastoral cows, their indigenously managed cows, and they were putting it in basically the same sort of big plastic bag that had a tube at the end of it. And so he was saying that the locals actually get like energy resilience out of that. Like they're able to power their cooking and food processing operations from the manure that was made by these cows. And he just had like several of these bags in different stages. And so I can send you that video. It was really interesting. And so that would be my answer. I don't know of anybody doing this. As far as I know, we're kind of the only people having this conversation. And as far as other tribes, not even this tribe, unfortunately, is really having this conversation, except outside of this room. When we talked to Mason about this, like the strategic energy plan, we asked about digesters in there. His response was that they didn't think it was feasible, so they didn't really look at it. And so that was disheartening to hear, especially since we know that baseload energy production is done in peaking capacity. So that's when there's like high electrical needs, everybody's home, turning their lights on, watching TV. That's peak load, but base load is just kind of the static energy needs. Think like hospitals and water treatment plants. Like they're always on, they need to be on for like safety purposes. That's what we call base load. And right now, a lot of the solar power, the wind power, it is intermittent. And so it cannot be relied upon for base load right now. And so really, there are three ways to generate base load currently. Hydroelectric power, which is a salmon passage issue. Nuclear power, which is a lot of considerations around nuclear power, and fossil fuels. Those are the three ways that we currently generate base load. So I'm really interested in the idea of anaerobic digestion because that has potential to provide base load. Again, lots of considerations on input outputs and like technological efficiency, but it seems from my very untrained eye that this could be an option for providing base load that is not one of these three. I think that help.
Yeah, definitely.
And then I missed this last night and I missed it again. Jenny asked about the water treatment plant. So this is something that this tribe is having conversations about implementing their own water treatment plant for water conservation purposes and for resiliency purposes. And we already know, Jenny, thank you for the city of Gresham example. they're just doing this already. You know, we talk about waste being digested in these digesters. It's not just cow waste. We could be doing this with people waste as well. And so there is opportunity for us to talk about digester implementation as part of a wastewater treatment plant in the future.
If there's a tour desired from any of your teams, we could facilitate.
I would love that. Yeah, that would be amazing. I mean, I had the opportunity to go visit 3 Mile Canyon Farm many, many years ago. And it's not a lot to look at, like it's just a concrete pit. It's hard over it. Like it's not very much to look at, but I'd be really interested in seeing the wastewater treatment plant. What else? Anyone online? All right, well, that was anaerobic digesters. Yay! Thank you. All right. Sequestration.
Can I put it up there?
You can.
A few additional slides.
Serious. No, it's that's the yeah. Subjects like the ones you hated. Exactly. Yeah, I think that's. To it, simple videos and the big that's what you can see.
You just set it up how you want it. Oh, there you go.
Right. So it's like. I was like, sharing. The labor guy was like, over can't do that. What am I gonna do? Like, you're wrong.
Here. I'll grab it while I'm thinking. Thank you so much.
And I'll take one too, even though I've got your email.
Felt pretty
I
awkward.
like having a physical card.
Good.
So I'm an old school person.
I just, yeah, I came to this job in the pandemic, so I thought I never had a reason to use them. Like,
All right, you ready? Well, since we just got a group, I'm gonna sit here and talk. That's fine, I'm loud. Okay, go on to the first slide there. Okay, so we, talked obviously a lot about geologic carbon sequestration last night. Like I said last night, geology is kind of an abstract thing. So I added some slides in here that show you a little bit more about what this might look like underground based on theory and practice from experiments. But also, I guess I just wanted to start with this kind of group, and I said it last night, is really important for kind of fact finding and discussion. So I really appreciate it. And actually the questions both on the poster, I photographed those, and from the questions that I took last night will be the kind of information we'll go and update our webpage with, like frequently asked questions or additional information. So these are, I just want to say it's really good environment to get that kind of information. And as I also said, this is kind of something new for Oregon that we're trying to get our head around. Not just the geology, I think we know a lot about the scientific parts of it, but there is a lot of funding coming to this. And so we have to address those issues head on. So with that being said, we looked at this last night. In basic principle, this is a cartoon of what geology might look like underground in certain parts of the country, not here, but it's a model from where you have production of coal or natural gas fired plants, and then the piping system that takes that carbon dioxide, moves it to a location of good geologic site conditions where it could be injected, that was the term we used last night, injected underground into a sealed reservoir and stored for a long time. Let's put it that way. Indefinitely, that's a better word. Use words I can say. Okay, go on to the next slide, please. Or actually, go back just 1 second. So the thing we didn't talk about last night, but obviously people have covered, and I also appreciated, was these different types of terrestrial carbon sequestration. I mean, we've gone through a lot of the different posters, elegantly outlined those different techniques. So that's one. We didn't touch on last night, though, that one of the biggest sinks of carbon is our oceans. And so there's natural systems that have operated for millions, if not billions of years to mitigate the carbon cycle within the the Earth's history. But it can also, there are ways to accomplish that actually by putting into the deep ocean additional carbon dioxide as well. So that is another avenue of research. We're not going to talk about that, but I did want to at least bring it up so we're fully aware of the entirety of the system. And then geologic carbon sequestration. And so I mentioned last night, those are traditional oil and gas reservoirs that have been extracted. Things can be put back into those. Saline aquifers, so it shows down there in the middle of the diagram, basically saltwater intrusions in old marine rocks. Many of you may not realize that actually underlying places like the Willamette Valley, where those are marine rocks dating back to 40 million to 45 million years, where the coast was there at that time. There's actually significant issues with saline water in those rocks. Ancient salt water, basically from those marine systems, and people have a lot of issues with drilling wells and producing out of them. So those type of, and they'd be referred to as brines, and in my next slide, you'll see those. You know, places like unminable coal seams, things that are not good production type coal, they don't meet specs to use. So those are places of potential storage, shale formations. And then really we're going to focus on basalt or ultramafic rocks is the term there. And basically in general, if you think about a rock, a volcanic or igneous rock, if it has about 50% of the by weight is silica, that's what we're talking about. And I'll talk a little bit further on about these volcanic or geologic formations around here, really defined by their geochemistry, which is their, to you and I would be our DNA. And so the simplest way I can explain that in the work that I do is if Whitney is an outcrop along the road over there, and I'm an outcrop, 3 miles away, and superficially in the rock hand sample, they look the same, and we analyze their geochemistry, and we find that you and I are identical, even though we're 3 miles apart. We can begin to make a map of those features and say, well, this was the same lava flow as the Whitney outcrop over there. And so volcanoes, when they erupt, they generated DNA similar to our parents when we were born, have that DNA that reflects them or our ancestry down path. So that's a simplified way to put it, but it's an essential component of this. And so we define rocks by their chemistry, particularly these basalts are about 50 by weight percent of them are a silica dioxide. Okay, next slide. Okay, so I wanted to give you a little idea what this might look like underground. So in the upper left, you see that kind of brown horizon there. That's what we call the seal unit. So this is a rock unit underground that has very low permeability and porosity. And by that, it means that a gas or a fluid does not move very well through that. So by porosity is the open space that would be available to put something into. Permeability refers to how connected are those holes and how well could that gas or fluid move through that. Okay, so a seal unit basically impedes that motion there. So we have to have a seal unit. We also have to have a reservoir of which to store things, and that's kind of that area under the seal unit. And in this case, this is a brine, a saltwater rich area, and so that CO2 plume is injected in there. And basically, from left to right, you see how the pore spaces between individual grains in a sandstone. That's the space that's available to store the gas. In this case, the CO2 is going to create a bicarbonate with that salt water and be stored within those grains. So this is kind of what geologic carbon sequestration would look like in some of these areas in the Midwest or traditional oil and gas plays where they're in sandstone type aquifers and might interact with really deep fluids. And so on the lower left there, you kind of see this is to see how the scale of the operation would look. So that circle at the top in just generic units of 100, that's kind of this bubble of the amount of CO2. And then, yeah, there you go, injected into the subsurface at depths of below 800 meters. So basically more than a kilometer is the target depth for this, of which then the CO2 becomes a supercritical fluid where it's somewhere between a fluid and a gas. And so that's what we want to get it into those spaces. And so moving on to the right, A there, so that's a representation of a layered section of geology, in this case, sandstones, limestones, marine rocks. You see, we've gone down more than 1 kilometer. And then in B, that shows you kind of the differences in a drill core. So that would be roughly 6 inches across and sliced in half. So as the drill goes down, it takes out this core. We can actually see the geology. The light white is the reservoir rock, and the brown is the cap rock seal. So if you looked at those microscopically, you'd see the detail where that cap rock doesn't really have spaces for stuff to move through. And then below it, it has open space. And in C and D, that's basically a quartz sandstone, really under a microscopic image. The blue is highlighting the pore space. That is the storage space of where material could go. Okay. And so I wanted to help people visualize what are we talking about? Okay, go on to the next. Yes, absolutely.
Does the brine, so if we're looking at Willamette Valley and they have help the process, or does it hinder the mineralization?
It's different.
Okay.
And I'll get to that in the end. So part of what I've gone to is there were some questions and concerns. So in my last slide, I talked about that a little bit. So let's go to the next. I'll hopefully get back to that. And maybe right here, I can get it to you. Okay, so structural trapping. So how is it trapped in subsurface rock formations? So we talked about you have an impermeable kind of cap rock. And here you see kind of this classic dome kind of structure. This is called an anticline, where rocks have been folded up. And this is classically where oil and gas has come from. And so that creates a seal, a reservoir, and then you have a geometry in the subsurface where you can store stuff. So residual trapping, that's basically where you put a plume into these type of sandstones, and as a supercritical fluid, it moves through the pore spaces in the middle. Yep. And then basically at one bubble at a time, it moves and drags the next one, and eventually that gets cut off and it's stored in that pore space, and that's where it stays. It doesn't move anymore. Solubility trapping, I mean, I mentioned that a little bit. That's where it mixes with the brine and the subsurface becomes a bicarbonate, and that's where it's stored over time. And then really what we're going to get to when we talk about the Columbia River basalt is mineral trapping. This is actually where it becomes a mineral rock phase, becomes a solid, and then it is really immobile. You can't make that flow again unless you substantially change the pressure, temperature, conditions of that rock. And so that's the special thing about working in the ultramafic rocks, the basalts that we have here in the Pacific Northwest. And basically that's where you have calcium, iron, and magnesium, what those rocks are rich in. Columbia River basalts, about 14% weight of that is iron. And that's total iron between ferric and ferrous iron. They have a content of magnesium about 4 to 5 weight % of the rock. And then calcium is about 10%. So a significant amount of those elements within the rock, they react with the carbon dioxide and make precipitate these carbonate type minerals, essentially turn it into rock once it's in space. Okay, on to, sorry I'm making you run, Connie.
It's
All right.
you.
Okay. We all need steps.
Exactly.
All right. Okay, so where could it be stored? This is based on USGS information, US Geological Survey, sorry for the acronym. In a number of studies that have come out both in 2013 and 2018, some national assessments of carbon storage, trying to figure out where, the first place you have to start is where could we put this? Even if we wanted to do it, where would we put it? So the first thing is kind of these saline formations across the Midwest, the north shelf of Alaska, off into the Gulf Coast. Does anyone recognize what the correlation with these areas is? This is, well, it's a traditional oil and gas production in the United States and in Canada, okay? Into the Gulf Coast, obviously we're all familiar with that, into the Alberta, Canadian basins there, and then the North Shore of Alaska. So these are traditional oil and gas plays, the marine type formations where those come from. And I'll point out, even into where Texas is there, the Permian Basin, I think we've all heard of that, West Texas, limestones there. Okay, we have offshore formations as well, and these also produce oil and gas there in the Gulf and East Coast of the United States and the North Shelf of Alaska. And then on the right, the basalt formations. And so these are really in the Pacific Northwest. It shows a little bit in Alabama and Georgia, but I think in the United States, we're really focused on the Columbia River basalt here in the Pacific Northwest. And it's one of the few areas in the Wallula Gap study that's been conducted there over the last decade or so has produced a lot of nice results, at least more understanding of what the system is doing if you inject CO2 into it. Okay, next slide. Oh, go ahead.
Just quickly on the Wallula Gap,
Yep.
because that is right here.
Yep,
So
it is.
again, very unique.
50 miles that way.
Yeah,
Yep.
it's drive actually. And so it was we're actually just learning about the Wallula Gap thing. It happened in 2013 and
Yep.
it was put to the side for like a period of time for some reason, unknown reason. And now it's being picked back up by the Department of Energy and the Pacific Northwest National Laboratory has been doing some analysis on it. So because of their now picking up that data and looking at it again, that's why we started hearing about it again. Or even the first time from my experience. And so this is something that has already happened. They've already done it. And so now they're in. It's just relevant that it's right here. It's literally in the tribe's homeland.
Yeah, Wallula Gap is out on the Columbia, everyone's familiar with where that is, just south of Tri-Cities. Kind of on the border of Oregon, Washington. All right, so we talked about this last night. I went over the Columbia River basalt. I won't read that in detail again, but that's the distribution of the Columbia River basalt in the Pacific Northwest on the left. That kind of orange polygon that covers the not tri-state area, it actually goes a little bit in Nevada and even perhaps a little bit into California. So a really regional unit, that's about 160,000 square miles in its distribution there. I talked last night also about the flow sequences, and I'll show you a little bit about that in the next slides. But really, it's those kind of stacked sequences of lava flows. The target becomes a relatively small area in the pink area. So the characteristic of the Columbia River basalt is those pink areas that divide individual lava flows. So a flow came in, buried the landscape, sat there for a while, kind of has a broken top to it. The next lava flow comes in, buries the landscape, sits there for a while, and so forth. We build up this landscape. At the same time, though, you don't just build up a landscape higher and higher and higher. There are subsidence that's going on as that landscape sinks, basically at the crust of the earth and the mantle interface with all that overburden. Crust of the earth has to begin to sink into the mantle. And so we get this really deep basin, the Columbia Basin, where I mentioned last night, the depths of these lava flows have been drilled down to at least 14,000 feet that we know. They're at least that thick. So this is a very, very thick area of these lava flows. As you get areas east and south, there are areas of where they're fairly thick, several thousand feet, but they generally are kind of lapping out over older topography and didn't consistently make this really thick unit. They even go out offshore into the Pacific Ocean on the Astoria fan as well. So, but the basic characteristic is it has storage room, this open space. But if you imagine it, the little grains of sand that we showed under the microscope, in the basalt, they might be large angular blocks that have large spaces between them. So as I mentioned last night, great for holding our groundwater. In this area, the Columbia River basalt is the region's largest aquifer system for sure. And these aquifers occur at multiple levels within the Columbia River basalt. And so that's largely what my studies for the last 20 or 25 years have been on, understanding how groundwater is distributed in these, and then how we can do detailed hydrologic modeling to really understand it. But now that modeling is becoming important for understanding this type of system as well. Yes,
Can I ask a
sure,
question?
absolutely.
Would you say it's a fair categorization? Space is for groundwater, and that's the space that we're talking about for this geologic injection, that it's kind of the same spaces I'm looking at, not necessarily all drinkable, but like all ground.
It's not the same space because, for instance, what I mentioned in my first slide, we're looking at, the poster mentions this, below potable water sources, but it's also greater than a kilometer, the depths that we're looking for. The deepest ag production well in Oregon, I mentioned a little bit last night, is in the center of the Grand Ronde Basin, and it's 4,400 feet. So, you know, that's about 1.5 kilometers, maybe a little bit more than that. So largely, this exploration is going to go far deeper than any of the water sources that we use now. And you run into a variety of issues as you get deeper because temperature of that water goes up. It may have its own mineralization that's gone on and contributed metals and things to the water. The water quality becomes in question as you go deeper. So I would say, no, not likely that we're sharing the same space, right?
But it's the same pore space.
It's the same concept and principle, but yes, the drinking water is not going to be displaced to hold this because they reside at two different vertical levels. Does that make sense, everyone?
Yes, thank you.
Okay, and so, and then just on the right, this rock is not, let's see, this is not Columbia River basalt. This is actually a sample from Iceland where they're doing injection like this. And so the basalt is the black, and that's a core, and the white is the carbonate mineral that's actually developed. So that is a CO2 gas that's been injected, has turned to a solid phase, filling those pores. And what the pores are called vesicles. When the lava flow actually cooled at the surface, it's a liquid. So if you've ever seen a video of that, as it cools, basically the reason that it cools is because gases start dissolving out of the liquid. So the gases in it keep it hot, help it to maintain a very low viscosity so it flows. But as it gets to the surface, all those bubbles are migrating out into the atmosphere. So that would be CO2 because volcanic rocks are a major contributor of carbon dioxide and other greenhouse gases. Yeah. So, but as that gas bubble leaves one at a time, lava flow begins to increase in viscosity, lower in temperature, and become a solid, and it stops. But when it stops, those are the remnant gas bubbles where that bubble went out of it, and you're left with that. And so then that is now the storage space to put carbon dioxide back in. Yeah.
Yeah.
Pretty cool, huh?
Yeah.
And so then that's a scanning electron microscope image on the left of a carbonate mineral. Yes, please. Yeah, moving on. Okay, so just I wanted to introduce a little bit. What's that?
Yeah.
So this is actually a map, geologic map. So I explained a little bit of it last night, what I do as part of my research. The multicolors in there are representative of all these different Columbia River basalt flows at the surface. Both maps are of the exact same area. The one on the left actually shows all the soil cover that people farm in the Athena area. And I should point out in the map on the very left side center, that's the city of Athena. And so the lower part of the map is the northern part of the reservation here. Okay, and it would be down Wild Horse Creek, down in there. All right, so the one on the left has all the soil cover over the top. The one on the right, we've actually made it so it takes all the soil off and just shows you the underlying geology in there. So these are the maps that we produce. On the left is actually a listing of all the flow units in the Columbia River basalt at what we call a member scale. So within those members, there might be hundreds of different individual flows, but I wanted to give you an idea. Each of these flows has been determined throughout the Pacific Northwest by making maps like this, analyzing the geochemistry of them, and then putting it together from Lewiston to Pendleton to Steens Mountain to the coast. And we've come up with this really detailed stratigraphy, and there's numbers up the middle of it that are ages. We've actually dated these rocks so we know what age and how they fit together. So just for example, with the chemistry, one of the flows called the Pomona that erupted in the Lewiston Basin at 12 million years ago, we can trace it by chemistry throughout the Columbia River Gorge and to Astoria. The analyses are the same from west to east backward erupted. So, but we've been able to create this chart of the order of lava flow. So I wanted to add that from our discussion last night. Yes.
Just to clarify, is this the updated effort that you're doing? I mean, at this level of geologic maps, like at this scale?
The map for the Columbia River Gorge will look like this.
Okay, and that's what you're working on now?
With the US with the US Geological Survey, and we use LiDAR as our base map
Okay,
for doing this, yes.
okay.
And so that is, yes, and it's not represented on there, but most of those places I've either driven or walked and collected samples on. And Katie Ely here from the reservation helped us with the southern part there.
Okay, so currently, is there something that you could look at to see the different types of basalt along?
Yeah, we have a web map on our website, so the entire geology of Oregon, we have a map for, and there's a web map. It's
You're in your individual, your agency's site?
Yes.
Okay,
we have, if you go there and you look at publications, it'll say, online data or GIS data, and we have a number of web maps that will tell you about hazards, landslide, tsunami,
Yeah.
and what you're looking for is geologic maps.
okay.
And it will have a web viewer that you can go in and look at the geology. Now, what I'll say, the map I referred to that we're making in that area, it will need to be published first, and then will be added to that as we add new information to it all the time. So,
Okay.
and it's the database behind it is called OGDC, or the Oregon Geologic Data Compilation. So if you have GIS folks, they can download it and then use the data in ArcGIS. Good question, though.
Thank you.
Okay, let's go to the next slide. Okay, so there's a small scale map, and at the bottom, there's this representation of a cross section. So this point, so you can see. This line here at the city of Athena, down here at Wild Horse Creek, that's called a cross section line, and the bottom is called a cross section. So if you took that map, turned it inside, and you sliced it down right across that line and then opened it up so you could see what the earth looks like, that would be that representation there at the bottom. And so these are major faults that break the earth's surface, and these are individual colors are the lava flows in space. And so a natural question would be, well, how do you know the order of those that go down 2,000 feet or so? And largely that's because at the city of Athena, we have a deep water well that goes down nearly 1,500 feet, and we've collected geochemistry on intervals of that and have been able to tie it to what we know at the surface, create this third dimension representation. So this is in order to understand carbon sequestration in the Pacific Northwest and its potential and feasibility. This is the type of thing that we have to know as a baseline of what the stratigraphy is, what unit we'd get into. For instance, in the Wallula project, they got into what's called the Ortley and Indian Field basalt. So in our stratigraphy here around Wild Horse, it would be down in this near the lower part of the section. Groundwater production in Athena is almost exclusively up in this upper part of the section. So just to give you an idea of how that's kind of divided around. I guess I'll stop right there. Any questions about this, what I'm showing? Okay. All right, next slide. We're almost done. Okay. I showed the point sources last night for industrial carbon dioxide in Oregon, and the lower left kind of breaks down by different entity, what their production looks like, power plants, the overwhelming kind of emissions there. I just wanted to introduce direct air capture because this is a project that is actually starting to go on in Oregon, where you take air out of industrial sources, you extract the carbon dioxide and then you put it back to some other purpose, like decaffeinating coffee beans or something like that. It's one of the ways it's being used. Or it's stored in the ground. So, I mean, this mentions some of the ways that applications that it might be reused and take it out of the system, or goes directly into underground storage. I didn't mention this last night, but it is something that we're not involved in directly, but there is a project going on. I can. Okay, go ahead.
Yeah, thank you for bringing up the direct air capture. It is something that we have here remotely because it's not to the extent that at least I know of. And it seems fairly energy intense to do this. So that was something that I kind of wondered. What is the energy? process, the injection, I know that you're not involved with capture, but the injection part of it. You had mentioned it's a super critical fluid. Thank you for that word. I've been looking for that word. I'm like, it's not a gas, it's not a fluid, what is it? And so from my understanding, again, talking to PNN, stored at a very cold temperature, but then it has to be heated up to be injected. That seems like that's a very energy intensive process. And so what is kind of the trade-off? Are we going to be burning coal to be putting carbon back into the ground?
You know, I'm not in direct air capture. I don't know the answer to that, but let me, the way I will answer it is that there's a feasibility study that's going on that we basically wrote a letter of support for the organization, a private organization, to look at
They got it.
in Hermiston.
Yeah.
And I think those answers will come out of that study. That's about all I can say about that, because we're not involved and it's a, private research.
So Wyoming.
Yeah. Okay, so anyway, I think the answer that you're looking for is going to come out of that study. That's where I will step out of my expertise and say, I just don't know that answer. Yeah, but it's a really great question about a lot of these. I mean, that's kind of what's been on the top of my head. Listening to everyone all day is, what is the energy trade-off for doing a lot of this stuff? Yeah. Right. Okay. Yeah. Okay. And then I thought about last night after I got home of some of the things we talked about are, benefits, but also the negatives, because I don't think I touched on that. And there were some questions about that. So that's part was really helpful. So I mentioned last night, this is the feasibility studies that people are going to do now and that we're going to be involved in, really are looking at, how could this be used to limit negative effects of carbon going into the atmosphere? It's one piece of a possible portfolio to investigate. That's where we're at right now as the state of Oregon. And really, I think the part I put in there, until these other carbon-free energy sources become available. And that's where we get into our connected studies, where we're looking at what type of critical minerals are we going to need to produce domestically in Oregon, because I mentioned it will come to Oregon or has come to Oregon, and across the nation. How are we going to do that in a environmentally friendly, green way, and considering the things that you mentioned last night about tribal relations and all the other impacted community. There you go. That's a good term for it. So basically, that's where we see carbon sequestration as part of a portfolio to get us to this part of a carbon-free energy sources. Okay. And so I just put in here one of the USGS estimates from a 2013 study where they looked at nationally carbon sequestration potential. And so in onshore areas and state waters, that's kind of the areas I showed you in those maps of the United States. There's about 3,000 billion or gigatons of subsurface capacity in the US. That's a very abstract number. What does that mean? Basically, it's about 500 times more than, in this study was 2015, so I put 2011, than what annual energy emissions are. So, and based on USGS findings, this is something that could get us through several decades. It's not a long-term thing. Remember I talked about last night, like there's a infinite amount or a finite amount of space you can fill up with this, and then that solution goes away. But the prediction based on this, at least in the US, would be several decades of.
Well, I just wanted to tour the PNL last, so they had kind of a 10-mile radius around the little area that they were looking at. And they gave the estimate of it could store roughly 4 years of the nation's carbon emissions.
Right. That doesn't seem like much. It's something. But
It's a stopgap measure.
yeah, that's exactly right. So yeah, that's a good way to put it. Okay, and then negative effects. So obviously, you do have the potential. The Earth is a dynamic place. It's not static. Many of these areas are seismically active, including potentially around here. We have historic earthquakes that melt free water. The Wallula Fault Zone heading into Wallula Gap is one of the more active fault zones in the Pacific Northwest. And we know that it has, in the time period of the Holocene, which is the last 10,000 years, we know that there are Holocene ruptures of these faults along the Wallula Fault Zone. So very active geologic environment in this part of the Pacific Northwest, but also including Western Oregon. We've all heard about the Cascadia subduction zone and its potential for mega quakes there. So some of the western basins that would be targets for this there are in directly seismically hazardous zones. So as geologic formations could change and break, you could have gas leakages. You could have, if they're sharing the same space, CO2 could get in and seep into underground drinking water. And then those reactions could release metals from the rocks that contaminate the groundwater. Certainly potential for that. The CO2, if it weren't stored properly and there was some kind of vertical conduit that got it back to the surface, you could have a revolving door cycle to get it back into the atmosphere. And then you wasted a lot of, like you say, energy and resources to accomplish this. But I will say about those first three is kind of in the Columbia River basalt. That's the point of looking at a basalt formation, is putting it down, making it a solid. When you make it a solid, then those top three basically are non-starters and are not really concerned. So that's kind of the benefit of going this way.
The reasons are region.
That's correct. That's correct. It's trying to get away from a lot of these risks, reducing risk. Nothing is without risk, but we're looking at reducing risk. And then the very good question that came last night was about induced seismicity or potentially create earthquakes. And this has been demonstrated from fracking and that kind of operations in Oklahoma, Louisiana, where that's induced earthquakes, in the Colorado basins, which were mentioned last night. So anytime you put a fluid under pressure into the subsurface, has the potential to shatter rock and change the dynamics of things. There's also interesting things that happen is when you create this reservoir, part of it is you have in that cross section, I showed these vertical faults. Those are kind of your bounding structures on the 3D area. And so you could mineralize into those and have carbonates go up into these fault zones and actually induce faulting or structural offset, could basically grease the skids. Okay, that could happen too. You induce offset on that fault where you didn't intend it. So a big part of this is really having studies that understand the constraints of the reservoir, understanding how the supercritical fluid is going to move through this, how long it's going to take to crystallize. That's what's come out of Wallula Gap, is basically, they put it in there, re-drilled areas around it over several years and see how it's crystallizing, what are the chemical changes that are going on, and trying to assess how is this fluid migrating. And then, of course, in our Pacific Northwest seismic network, I'm trying to see, is there induced seismicity? Are there micro fracturing or quakes that are going on? In those drill cores, are we seeing micro fracturing going on in the reservoir? So that's part of the gap study and what you look at over time. And then developing what are the pressure management techniques. You might have to babysit this thing forever. It gets into how much resources does it take to do this. Yeah, you can't inject it and leave it. I mean, that's even true with oil and gas. That's a very dangerous proposition when you're putting a hole down 15,000 feet. The pressure conditions, I mean, there's plenty of examples of explosive wells and things like that. So it's a dangerous proposition, or can be. As far as we know so far, with the amount of these types of operations that have been done, this is a rare occurrence of induced seismicity. But like lots of scientific things, longer studies are going to be needed, more detailed studies. So, all right, I think I've talked long enough. Oh, I just want to make you aware. So in neighboring states, Washington Geological Survey, they've put 4 people employed in their survey to look at this, assess sites, and they have this very strong relationship with PNNL. The California survey to the south, they have 3 major projects going on, and 3 people have been advertised to fill those positions at the end of the summer. Nevada's got some involvement in carbon sequestration, and Idaho is looking more at these natural climate solutions. And so Oregon, basically right here, we're having information gathering to see where we go with a program of study like this.
And like I had mentioned, University of Wyoming.
Right, it's Rocky Mountain. Yeah. All right, that's it.
really just wanted to thank you for providing this information to us. Like, we're really catching up on this. And I know that you have said that your department is catching up on this too, but we're starting from really the basement and learning about all of this. And so not everyone would come to our longhouse and present. I actually just really wanted to thank you for coming out here, taking the time to talk with our community about this. Does anyone have questions?
I apologize if you mentioned this. I know you said you're learning about the length of time it takes to mineralize from this study. And that's part of doing more studies, but like when you showed that one example, core in Iceland, or even just what they've learned from the study here, like, what are you talking about? Like years, months, like how long till it starts to fill in the spaces?
Less than 2 years.
Okay.
Yeah, so in Wallula Gap, they have some initial, well, not some, a lot of initial cores that go down. And where you see rock that basically be barren of this type of mineralization. So they injected CO2 into that at a certain depth. And then basically after certain years, a year, 2 years, have re-drilled through those same sections and looked at, okay, what is the mineralization now? And so basically then you start to see cores come up like this. And they're not just naturally appearing like that. Because they're also putting isotopic tracers in here. So they know it's not naturally occurring carbonates. It actually relates to what they put in. So it has basically a tag that's been put in it so we can identify it again. But basically they started to see this show up after 1 to 2 years.
Very rapid. Understanding at the end. Their estimate was.
Yeah, that comes out of the latest 2018 USGS report on carbon or geologic carbon sequestration. That's the information I have.
Again, another reason our area mineralize and become a solid, it does it very rapidly.
Yep.
Yeah, I think that's great. Thank you. Great, before we go to our last two, we just want to roll through. Are you guys feeling? Let's roll through, see what it says.
Get out to that nice day.
Yeah.
Your backup pull up your toaster? Yeah, sure.
Oh, you can close that.
I don't know. I think you first.
There you go.
Am I pulling up your poster? Yes, please. I can pull around it too if you want.
That might be helpful. Well, I'll just start while Colleen is zooming in on our energy poster here. My name is Karen Appler. I am the Senior Outreach Manager for the Energy Trust of Oregon, and my role within the organization is a rather unique one. I am based in the Pendleton office pre-pandemic. I was only one of two folks that did not report to the Portland office every day. So I have a focus in geographic community of Eastern Oregon, the Gorge, and part of Central Oregon, as well as tribal communities statewide. And Energy Trust of Oregon, for folks who are not familiar with the organization, we are a nonprofit that was created as a result of legislation requiring the investor-owned utilities in the state of Oregon to have energy efficiency and renewable energy programs. So we support the utility customers of Portland General Electric, Pacific Power, Northwest Natural, Cascade Natural Gas, and Avista. Particular to the UIR, we represent Pacific Power and Cascade Natural Gas. And of course, about 50% of the energy is delivered by Umatilla Electric. And Colleen asked us to come and present today a little bit about energy efficiency and renewable energy programs that support offsetting energy usage that helps reduce carbon. And I have a colleague, I think she stepped out, Jenny Hall, who was the senior program manager for our solar portfolio, who has now moved on to a program manager role with our Communities and New Initiatives program, which is really focused in around resiliency, which is also another aspect that we talked about a lot, even last night, about energy usage and power generation. So on this quadrant of the poster that we have, which is also here at the Governance Center, which we would welcome anybody who's listening in to invite people to come and see.
We have a virtual rotunda.
A virtual rotunda too, and it would be really great to, I just welcome any questions that you have. I think bless you. I think particularly for this climate adaptation discussion, energy efficiency and renewable energy, it can get really technical really fast, and we kind of lose that practical aspect, which is why I love the conversation DeArcie had about composting. I feel like it's something that we can all relate to. We all eat food byproducts and things like that. So please, I welcome questions. They really help us tune our thought processes, but also the language that we use with you all to make this stuff understandable. So we have this quadrant to really talk about what I think are cornerstones in this energy efficiency and renewable energy discussion. And I think the first discussion point is the conservation aspect. And really that's the less energy we use, the less carbon we're emitting, and really talking about how I really think about the building envelope as part of that, and in sort of the built space, the built environment, and also just energy efficiency, really the different types of technologies, whether it be heat pumps or variable frequency drives on irrigation pumps, and refrigeration that we could have. And then I think a lot of people want to talk about things like renewable energy, which obviously is power generation that can help offset that coal use and things like that for power plants. And then for electric vehicles, Energy Trust doesn't really get involved in that particular environment. We are not part of the EV. We don't incentivize electric vehicles. We don't incentivize the infrastructure for them, but particular for that, we have been involved with energy planning efforts that have included huge portions of that, including the tribes discussion of that. I think with rural and tribal community, sort of having that demand for individual consumer level stuff, I think is a little further out for the communities that we're supporting. But thinking more on the scale of package vehicles, any vehicles that begin and stay in the same spot. There's certainly a lot of appetite from the agricultural community on EV equipment that makes sense for the operations that they have. And just the other things I saw on the poster this morning, which was great to hear, which is having walkable communities and public transportation methods that lower that individual usage, which is so great. The other part, which I have an expert, Jenny Hall here with me, with reliability and resiliency. We know that power disruption is a real issue with our rural and tribal communities who maybe have challenges with the infrastructure that they have. So we're talking about things like power generation, battery storage, microgrids that would allow communities to receive power generated from battery storage if the power goes out, and other things to make, like as I was mentioning before, that building shell that could help the ambient temperature remain at a constant level in extreme temperatures due to natural disasters. And then the last thing that I think a lot of people want to talk a lot about solar, which is a wonderful resource, but we also know that the sort of materials that go into building solar are not carbon-free. And so the diversifying of your renewable energy portfolios, I think, is a very big consideration. And it's particularly in the tribal spaces. There was just this great conversation that happened in the Northwest Indian Housing Association a couple of weeks ago, when it was just, we were really talking about, well, these things could all complement each other. And again, it's a part of a portfolio of things that can and should be considered for our communities.
maybe down. And part of this, when working and coordinating with Colleen, was really providing a sort of a snapshot. This information was provided by the state of Oregon on the different types of fuels that are being used for energy. And you can see that there's a lot of opportunity there for renewable energy, but also just decrease of energy usage. And obviously that's really within the role of Energy Trust. The subject of transmission lines came up last night. And I would say this, which is we don't really have a role in that. Our sort of governing Oregon Public Utility Commission is the one who oversees the utilities and that particular topic. But our role is really to help lower energy usage and increase power generation in that mix. So we'll just kind of leave it at that. But hopefully you all will use the virtual rotunda to dig in on this topic. I don't think I have a ton to say unless that. And then maybe go up to the right.
Kitty corner.
Thank you for driving.
Yeah, thank you for this amazing poster.
That's for all of you. Yeah. Anytime we can get in front of the community is great. And I really enjoyed participating in the climate adaptation series. So this is a little bit of a snapshot of I actually just got approval from Mason on this. Will be a resource on CTUIR's website. What they were finding within their energy strategy team and the energy plan is that a lot of tribal community members are coming and they want resources on how they can use and apply these techniques, energy efficiency and renewable energy efforts at home. And so we worked with a couple members of the energy team, Mason Murphy, Monica Paradise, Marcus Luke, Aaron Luke, on development of a piece that tribal members can have that shows all of the different resource providers that support residential housing on the UIR with energy savings and renewable energy. And I think one of the other things that I didn't mention last night too, part of the desire for this piece was that with the IRA and some of the new initiatives coming out, we're also seeing that solar companies are getting super aggressive in the residential market and, potentially like some predatory behaviors that we're seeing. And we just want to really emphasize with the community that while renewable energy is wonderful and it certainly should be part of the considerations, that there can be a lot of conservation and energy efficiency that is actually providing carbon reduction at a lower cost to those individuals, and also building in in addition to thinking about things like solar and battery storage, there's things like building envelope and mechanical ventilation and just decreasing that energy usage is really the sort of lower hanging fruit in this conversation, and that so much can be accomplished with insulation. And I mentioned my own particular circumstance of living in a 1914 kit house that when I moved in, had a 1940s electrical service. It had knob and tube wiring. It required a lot of service upgrade and patience and money to even get me to the point where I could get attic insulation. But boy, did that make the biggest difference in my utility bill. So we really want to emphasize those types of things with community members as we talk about things like power generation, which is like the more, I think, fun thing to talk about. You can't really appreciate the insulation in your walls unless the power goes out and it's very cold outside, and then you realize what difference it's making.
And there was kind of one point that I wanted to bring up last night was that there were additional benefits. I found out that the insulation in my house was very terrible. I have a 1941 home. Not much difference, different wiring. But the reason that I found out that the insulation was when we had that bad smoke event in 2020 in September. My air quality was like 200 parts per million in my house. My house is like just feeding to the outside, and that's an energy consideration as well.
Yeah, air leakage is a really big deal. It's part of the thermodynamics of a building envelope, but you really have to understand that, you know, hot and cold want to exchange places, and mix. And when you have any, air holes in your house and I don't know what it is with me in old homes, but prior to moving to Oregon, I lived in Maryland, and we would certainly have these cold snaps, and the keyhole in the front door, you could feel the cold air shoot through and hit you in the back of the neck when you're trying to watch television. So, I mean, anytime that you can remove those air leaks in the house and insulate well, you're going to be more comfortable, and you're going to have less contaminants enter.
Like what you're saying there, except for in the advising people to do this, are you considering the effects that this would have on radon? You know,
So yes, and we do have, there's a requirements for, and code is bringing this to mechanical ventilation. Bath fans, kitchen fans that are on a timer, to do that. We don't have, is my understanding, in the residential market in Oregon, a lot of problems with that, is what I have been told. You might have, with your background, a different sets of that, but at least in Eastern Oregon, I don't have the same issues. But there are requirements for that mechanical ventilation. So if you are going to seal a home, mechanical ventilation is something that you want and need to do.
no, that's good. I'm glad you're thinking about it. And yeah, it is something that's important to me. I published a study on radon in Oregon, so I've got a map statewide of radon potential that we put out as an agency. We have actually an online web viewer that I talked to her. You can actually look at radon in Oregon. So I'll just send you the information for that.
Our residential team would be interested about it. I should also tell you, I'm a generalist for the program, so I'm not deep into
Oh, I understand.
all of that. But, and I don't know if you have any perspectives.
Ventilation, that's, you know, Karen Chase just gave me some information about that. Ventilation is always challenging because there's no incentives for putting vents on the roof. So that is an issue, but.
It's just something I'm glad you're, thinking about it. And I really appreciate your answer. It was good. It's just that, as we become more and more efficient with building, this is one of those side effects as you seal things up, and, local site geology can contribute a lot of radioactive minerals to this potassium, thorium that exists. I just say for one example that the site geology is we don't think about radioactive materials much, but actually the sands that underlie Boardman, Hermiston, and on down the Willamette Valley, those are actually derived from places in Montana and the Upper Craton in Canada, which contain lots of radioactive materials. And so those can be part of the sand deposits and even granite boulders that were transported. And so we know that those produce radon gas and things. So I'm really glad you're thinking about it.
Yeah, and on top of that, I just wanted to say, like, the things that we bring into our homes, they also have off gassing.
Right, yeah.
So that manufacturing process, there's a lot of evidence. For quality hazard.
Yeah, and that, in the scope of all things in like healthy homes, it's like if you're cooking and you're not using your oven fan.
Nothing's like my air quality.
Yeah, exactly. You should always be using that. But thank you for that point. I also, growing up on the East Coast, like a requirement to have a house. So I think those are other things that, part of the discussion when we talk to community. I think that is it. Oh, just super quick too, because it touched on something with talking about heating oil and other programs. So typically energy efficiency and renewable energy programs are dictated by the primary heat source of the home. So with energy trusts, if a home is not heated with Pacific Power or Cascade natural gas, it doesn't mean that it's not eligible for an energy efficiency program. It just might get directed elsewhere, which is why we wanted to show this like graph. The state heating oil weatherization program is a percentage that bulk fuel providers actually pay into a program that homeowners can access. I believe it's up to $10,000 per home, and it includes things that we actually don't incentivize, like weather stripping. indoors. And then you have Umatilla Electric Cooperative. ODO has a portfolio of programs, including heat pumps. And then CAPCO is a community action program, Oregon. Yep. Yep. And they also provide services for weatherization, and they have increased incentives based on the income of the person who's living in the house. And then, of course, housing for folks in managed housing that actually work with us. And then, I just thought this was really important. I wanted to emphasize and also honor all of the work we have done with CTUIR. I would actually say that the community is the leader in Eastern Oregon in embracing our programs. Back in 2005, the Board of Trustees passed a resolution to include energy efficiency and renewable energy readiness for renewable energy into all new construction programs. And so they have been a partner, a collaborator on a lot of these things you see here on the screen. The most recent is the multifamily project, which is net zero. It's using as much power as the solar array next to it is generating, which is really exciting. And that feeds into the renewable energy piece. And then, you can see a smattering of other projects. I know we were also talking about some other things, but I think I wanted to bring this up and I didn't emphasize it. So strategic energy management, you had two sites. Wild Horse is no longer active just as a staffing capacity issue, but that IUS Technologies is still active with the program. It is basically we pay to meet with larger campus organizations. We have an energy sponsor that we work with as well as a team. And we actually identify low energy saving opportunities up to capital improvement projects. And we pay in addition to our incentives for the time meeting. And then we provide like a toolkit, energy coaches that we call them. And it really helps identify those savings opportunities on a large scale. And so we'd like to get back to working with Wild Horse. We'd love to work with the other government buildings as well to identify those savings opportunities. That's like a year-over-year thing that can be put into things that are identified in the energy plan as well as the climate adaptation plan. And so I think that's another opportunity we could.
You talked about predatory solar companies.
Well, I think we have a website, and I should leave it to you to talk about the trade ally, our programs are delivering.
Yeah, so so that was one of the kind of foundational elements of the solar program with Energy Trust. It was to create a network of trade ally solar contractors around the state. What we do is, and we have something similar on each of our programs, so energy efficiency. We have requirements that the contractor be licensed in the state, which is important, that they maintain insurance beyond what the minimum the state requires. Then we go into more detail on how they interact with customers, how they design projects, because for a solar system, you can design a solar system, you can install a solar system that meets the electrical code and meets the building code, but it would never produce electricity because the building code isn't focused on performance, it's safety. So there's kind of a gap there. And so going to the Energy Trust website, we can connect you with contractors that we work with. And they work both inside and outside of Energy Trust territory. They work all across the state. And so that's always what we want. That's always what we try and say is get a couple bids. Even if somebody comes to your door, maybe they're a great contractor, but you always want to get more than one bid for a big project.
Always use our website as a resource for contractors who vetted. And I don't know, is there anything you would add about the resiliency aspect? And
yeah, I guess just a couple things adding on to what we talked about last night. The conversation kind of reminded me there's a lot of opportunities with electric vehicles to intersect with some of these other community goals. So like with resilience, Hood River County actually is working on a school bus EV project that can provide resilience to their, to a community hub. And so when you think about, passenger car, that's still a pretty big battery. When you put a battery in a school bus that you only use it 12 hours a day, that's a big moving battery that you can use for resilience, and that can plug into a solar storage microgrid someplace. So those sorts of opportunities to connect the community's goals with some of the funding to support carbon sequestration. And I guess the other thing on energy efficiency and renewable energy that there's a lot of things that we're talking about that are new, like you were saying, that it's changing the way we're doing things, it's adding something new. There's also all these opportunities, especially when you're talking about energy efficiency and renewables, to kind of build off of things that are already happening. There are plans to build homes. There are plans to there's work that's underway that it's about like just augmenting a little bit. So it's not like a whole new thing, and because there's always going to be things that are just new that we have to do.
Thank you. I love that I'm wonderful discussion. This is why we need a. But we have one more excellent conversation. Community Climate Investment Fund.
Sure, and I sent you an email that has the PDF in it.
Yes, you did.
But I guess while you're pulling that up, things that I didn't put in there. Again, I'm Whitney Doerr, and I work for Department of Environmental Quality in the Office of Greenhouse Gas Programs. I've been with the agency about a year, and there is just so much to learn in terms of the other programs that our agency is running as well. And what comes to mind is food waste. There's a whole team of materials folks that do materials management, and I hope to connect you with the two individuals that I've talked with related to our food waste programs.
Okay, nice.
At DEQ. And there's every year an annual food waste prevention week that happens, and there might be some really cool collaborative opportunity to highlight what you've done related to composting. And yeah, I think that there is some really room to grow there, and they hope to grow the programming. So again, I work for the Climate Protection Program. You can go to the next slide, which is our declining cap on greenhouse gas emissions with a goal of 50% reduction of greenhouse gases by 2035 and a 90% reduction by 2050. I also want to highlight something I didn't mention last night is that it's not just this program isn't just a regulation on fuel suppliers, but it's also on stationary sources. So places that are emitting carbon dioxide and how they will be brought into the program is just beginning now. So this year we brought in our first kind of covered stationary source, which is Amazon data centers. And so they are coming into the program, which means they have to do an analysis of what their energy usage is and also what their emissions are. And they have to provide to DEQ a best available emissions reduction plan, a BEAR plan is what we're calling it. And DEQ gets to vet that plan to say, we think you can change these certain pieces. The public can also comment on these plans. So I want to encourage you to go to DEQ's website. And if you look up the Climate Protection Program, they've posted their recent, proposal for what they would do to reduce their emissions. And we are kind of at the stages of moving forward with that. So lots of opportunity for engaging in what's happening in the Climate Protection Program since it's so new. The way that these goals can be reached are cleaner biofuels, increased electrification, energy efficiency and demand response, and also new technologies. Since this is a long-facing program, there are things that we could not even be considering today that could be a way for us to help reach the goals for this program.
I just commented that, could you define what demand response is? Because I think a lot of.
I think you could do better than I could.
Actually, Jenny could.
Okay, Jenny, go for it.
Demand response just is, it's a program that is where energy efficiency is decreasing energy usage on an annual basis, but you're looking at it over time. Demand response is assuming that there are points in time, if you think about like almost like a mountain landscape, that's what the energy usage in a community looks like. And there are points in time where there's a peak, like on a really hot day, everybody turns up their air conditioning all day. And demand response is trying to get that peak down, because with the utilities need to produce enough electricity to match every single one of those peaks. And so that means that if it's coming on, if it's unexpected or it's unusual, then they're going to have to ramp up a natural gas peaker plant or
Behavioral then, or like, is it?
Great question. It's both. So PGE has a program where they send you a text message and they say tomorrow between 3 and 7 p.m. limit your usage because everybody's coming home and it's going to be a hot day and you're going to have a peak. And so you can just choose to wash your clothes later, things like that. Or there are programs in place with CPRG and PGE where if you have like a Nest thermostat, have a smart water heater, they can if they turn everybody's thermostat down 1 degree, you might not notice it, but it helps bring that peak.
I have a question, I'm sorry to.
No, this is what it's for.
You're off what you're talking about. I've heard things about people who are behind on their bills. They can turn like your heat off from the push of a button. And you don't have to go over that with some of these things. That feels like a huge concern for a lot of might otherwise. Yeah.
You mean with like a smart?
Yeah.
So basically,
Yeah.
in their same ability to turn everyone's down by a degree or two.
And like the auto driving car can do both, push a button. So like that's a consideration.
Equity is a big consideration with demand response because you can imagine that not everybody can tolerate a 1 degree decrease in their air conditioning because some people need it to are elderly. Folks need to have control over their thermostats, and so equity is a big piece of that conversation. And demand response is new, so it's a good thing to keep with the.
Yeah, you can go to the next slide. So I talked about this last night, but I think it's helpful to see this visual in terms of what the one component of the climate protection program allows covered regulated companies to pay into a fund instead of reducing their emissions. It's a portion of their compliance. It's 10% is able to be utilized for this investment program. And we are in the midst of building it. So no funds exist today, but we imagine that many funds will exist in the coming years because our covered fuel suppliers will be needing this compliance option to reduce their emissions. So we have our fuel suppliers on the left of this document earning community climate investment credits by contributing funds to a third-party entity. And this is the group that I mentioned last night, Seeding Justice, was just announced to be a group that we're working now with in contracting. I'm trying to get them in contract to receive these funds and then implement projects through other partners, through on-the-ground implementers that reduce greenhouse gas emissions in environmental justice communities. And something I didn't mention is that we do have, again, for just accountability, built in an equity advisory committee. It's a 10-person group from around the state that has been meeting over the past year and will continue to meet as we develop the program to help make sure that DEQ is living up to our goals related to equity and prioritizing these investments for environmental justice groups. So the next slide shows the list of folks who are on that committee right now. And Mason Murphy, who has come up a few times today, Mason sits on this group. But I do hope that we continue to have, as certain folks step off of the committee, representation from Eastern Oregon and definitely making sure that there is interest to participate in these meetings. So we have a public meeting this next Wednesday. It's a meeting to talk about the seating justice contract and next steps. It's a public meeting and there is a public comment period at the end of it. I can share that out, or you can find it on our website if you search for the Equity Advisory Committee. So it's still a pretty new group, but they will be having a lot of feedback opportunities for moving forward in projects, like what projects are funded, where are they funded, what are the challenges to those projects. And then the priorities for these investments are reducing the greenhouse gas emissions and other air contaminants, promoting public health, environmental and economic benefits for environmental justice communities, and helping to mitigate those impacts of climate change, air contamination, and energy cost. And then also accelerating the transition to clean energy, particularly in our environmental.
Thing that I always bring up in spaces where I hear the phrase clean energy, no energy without harm.
Yeah.
Informed decisions about which harm.
Yeah, and in a conversation with Mason, actually a little while ago, he was just like, you know, really, questioning that term, and also questioning, like, you know, everything has created problems to this date. So like, how do we continue to make those informed decisions, understand what the challenges and the payoffs and benefits are moving forward. So these are just some visual representations of some of the things we've heard that people want out of this type of program. Charging stations for electric vehicles. We've got electric heat pumps, charging in electric buses, and medium and heavy duty, you know, equipment that could be more for industrial spaces. And then again, you've got solar up in the corner, which we've talked a lot about too.
And driving in this morning, I saw those deckless heat pumps.
Yeah. That's it. Yeah, no, the last slide was just that seating justice is now in this space. So I'm really excited over the next year. We're really going to be diving into like what types of projects there could be. What are the concerns from community about where these projects are implemented. And we've talked a lot about like those barriers, like what are the challenges faced to actually getting the on the ground work done. Yeah.
I probably have a couple. We need good presentation. So I'm interested in for like agency to agency in your goals and priorities. So in your slide there, reduction in greenhouse gas emissions largely seem to be related to electrification, biofuels, and those kind of things. And then the last slide was about reducing greenhouse gas emissions, environmental justice communities. So I guess in the topic of everything we've discussed, where does sequestration or taking carbon out of the system fit in DEQ's?
Yeah, currently it doesn't. And for the community climate investments. So that was a big discussion during rulemaking. I was not around during that rulemaking period, so I wasn't a part of those conversations, but there were definitely desires from, especially a few of the rulemaking advisory committees from Eastern Oregon, to be including sequestration into these project types. And there is always the potential that this program can broaden the scope, but I think that there was a fear that those could be, offset type programs that would not directly see those benefits of the energy transition to environmental justice communities. So I think that, we have an every 2-year program review. And I imagine this will keep coming up, which is, how can we potentially use this investment option for sequestration projects?
Great. And then the last question is, the last part of your last slide was about accelerating the transition to clean energy. So what is that? Like just in general terms.
Yeah, I mean, that is considering so projects that could provide rebates for electric vehicle use, and having folks transition from one source to another, all I would say would be something that would kind of flow into that. Yeah.
Would our human power for food waste diversion qualify for these funds?
Yeah, that's a really interesting idea because I think that I would say yes. And I know that there were some questions as I brought this up to like, our legal folks too, like what does that mean? But it's an anthropogenic greenhouse gas emission and
There are calculators that exist that you can quantify.
yeah.
The carbon benefit.
Yeah, and especially with the anaerobic digesters, it actually came out of somebody from, it was a conversation with the CAFO, with the, and understanding like, is that a potential for a project for the confined animal operating basis? So I think yes. We just haven't yet decided, like figured out what that could look like.
Like all of this is still really new. And so are there any other questions for the climate investment specifically? I think I'll close it out. Again, the discussion is diversification, right? Like no one of these is going to be the option that solves everything. There is no silver bullet. We have to figure out what we can be doing, what is appropriate, what is the community is accepting of, and what's going to draw down carbon. And like we talked about last night, there is a real need to do it rapidly. But also a real need not to continue to replicate the problems that have brought this to our doorstep. And so I'm really grateful to all of you for doing all of this. I think that this could be a really great committee, you guys. So I'm just gonna put that out there. Not offering funds associated with it yet. But does anyone have any kind of closing thoughts that they would like to leave us with on what you've heard and learned today and yesterday?
I'm thankful for the support in this area and
Definitely learned a lot. Thank you all for being part of that. Amy, that's.
Yeah.
Thank you for facilitating. Yeah. Again.
Comment would be that packet of posters you put together was pretty nice. Are you gonna put that out somewhere or make that available?
Yeah. We'll email that out to our listener. We do have a virtual room that I don't know if it's being heavily utilized right now, but that's up there. We'll continue to use those posters. Thank you for helping develop those and.
One question too, because it's kind of goes back to what I was saying, when they was speaking, which is I would love to hear what the community is. Like all of those questions, all of those thoughts. Furthering us. Support.
I think that once I recover from putting this on, I'm going to come back to all of us. And you all heard different conversations. That's the thing is we all got snippets of it. And so I would love to bring this together and sit down and maybe virtually with all of us and write something out about this. Like, what did we talk about? What did people say about it? Because we are at square one for this and there's a lot of money out there. Drugs in the water. And so this is something that we are also trying to get. Thank you for being part of that, like first understanding. Yeah, I would love to try and remember all of the conversations that you had and we'll take pictures of the posters and everything. We need to be writing this down and yeah, continuing these conversations.
Beyond ODEQ, we could start a conference series because most of the time I'm going to my conference in my field, never know what's happening. So I think this is a good mix and interest. All these different solutions come together.
Easily filled this time, like
Yeah.
we're not even supposed to be running this long. And so there is a lot of conversation here. I agree, the conference would be great.
Yeah, and it's just the ideas are percolating around, that overlay of the basalt map and the map I showed of the 4 treaty tribes, right? It's like, that is the area. So I think anything we can do to have some regional conversations, because you're the one who introduced just an open invitation to talk more about that. And also I was wondering about the slides, because there's some additional content on the slides, which was really helpful too. Could we ask if people were willing to share just to us?
I know that you took yours back, so if you wanted to.
Let me look at my slides and then I'll see. 'Cause
Okay.
we have a
Yeah, I wanted,
protocol for publication release and stuff. that I
Yeah.
have to-
okay, that's fine. But definitely the posters were super helpful. I shared that with a couple of our staff already in there.
Yeah.
It was really good.
Yeah.
Yeah, I'm not sure. A couple processes, but are the other Oregon doing similar processes, or is there maybe an opportunity for some support?
Yeah, definitely. Well, especially, so with community climate investments, I'm really excited about Seeding Justice as they have some natural connections to tribes and have funded a number of the tribes previously in their funding grants. With the climate pollution reduction grant coming from EPA, none of the 9 federally recognized tribes in Oregon received planning grants, which was really why we wanted to bridge collaboration and understanding. Affiliated tribes of Northwest Indians did receive a planning grant. So I'm not sure, I've been trying to stay connected to understand their process and what they will be doing moving forward. Also, Graham Rond and Coquille were the other 2 that kind of reached out to say, we want to make sure there's space to have our priorities listed in the state's plan. So there's an Oregon Environmental Tribal Forum in next week or 2 weeks at Graham Rond that I'll be going to, that is kind of more for all of the Oregon-based tribes to come together, and EPA helps facilitate that. So I'm curious to see if there's other ways to support at that gathering.
Can you send me details about that?
Yeah, definitely.
Yeah, can you just say the name again? Because I just was talking to the cultural resources staff from Grand Ron, and I think that's what he goes to typically. It's all of the Oregon.
So this is an annual conference. I've never been before. It's called the Tribal Environmental Forum, and it rotates which tribe hosts it. This year it's at Graham Rond, and it's on the 17th and 18th. And I can email the person I've been communicating with to see, like, I haven't seen any posting about it, so I'm not sure whether it's just like a,
Yeah, I was just curious.
Yeah.
Thank you.
yeah.
It would be, there's certainly a lot of opportunities for maybe shared resources, or at least shared learning, and fortunate to miss an opportunity to bring in PA funds to support, because all of these conversations, I'm sure, would be duplicated at Grand Ronde and
Yeah.
Will.
I mean, I do have to say, like, I've really, it's concerning to me that EPA is working on such a fast schedule. And this funding is only available once. At this time with this IRA funding, they're really, I think, fearful of a change, a shift that could mean, that funding disappears. And so it doesn't feel like many tribes will be able to be successful in like getting it together in time. So that is a huge concern that we have, and we voiced that to EPA to say, if you really want meaningful engagement to happen, it's not on this timeline.
This might offer the event that was occurring with the Economic Summit. We were part of a breakout session with energy planning, and I don't feel like the greater we, like all the faces around the room, understand the constraints that tribal communities face on doing these projects, like all of the regulatory compliance that they have and all the hoops that must be jumped through. And, most of the projects that were talked about, CTUIR being one of the representatives, you're talking like a project on a 10-year horizon just to get through that bureaucracy. And I feel like we just don't do anything to change it. And I mean, it's very difficult. I think it's probably going to be very frustrating on the planning and economic development and financing side.
Strategic decisions. Sure. Well, I would like to say thank you and get out of here.
Thank you, Colleen.
don't have the room any longer. There's like people like, I was worried that Karen was coming to tell us about all day. Yeah, so my plan is to leave the posters up in the rotunda for into next week so that people can participate on them. I'll continue to check in with them on that. But at some point